Hello, I just wanted to go over the test that you took last week. And I just wanted to let you know that the majority of you did pretty bad. And it's actually very disappointing to see that some of you don't even try. I mean, what you're about to see and the answers they are about to see are like extremely easy. You don't have to do anything. The only thing you have to do is pay attention and read the problems. Like some of you are not even reading what the problem is saying. And I think the bigger issue that I see for some of you is that you're not even trying. Like some of you are not even trying. And not just me, but other teachers also put a lot of effort into these lessons. We spend hours putting this together, and some of you don't even bother to open or watch the videos. I get this feedback from you, and I know the ones that said that the videos are helpful, watch it, but the other ones, I don't know how you expect that you're gonna do well in an online platform when you don't even do anything. Okay, so next semester we're probably gonna go fully online, and some of you are gonna go to pre-cal, some of you are gonna go to statistics. I was looking at the list of people who are going where, and I was just like, whoa, I don't know how they're gonna pull this through if they're not even trying right now. That is just 7 weeks, let alone the entire semester. So if you're one of those who usually don't care, I will suggest you start caring, because things are gonna change next semester with the grading. I'm assuming like it's not gonna be any more of credit not credit, because you're supposed to get, I don't know how things are gonna go, to be honest with you. But for sure is that it seems that this is the new norm even for the universities, and they're not babysitting anyone at the university. And it seems that here it's like, okay, if you don't try, it's fine. No, it shouldn't be that way. Okay, so good luck if you're not doing this stuff and if you're not trying. At the end of the day, the only one that gets hurt is you. Okay, thank you so much for those of you who actually try and do the things and ask me questions and send me emails. You're always getting 100%, so you're always getting like those high scores. And honestly, there is no reason why any of you shouldn't be doing well on this particular unit. It's very, very low computation math, okay? It's mostly reading and analyzing. And next semester, you're gonna have a teacher that's way better than me. I hope so. But you at least have to try, okay? You might say, well, you suck, you don't know how to teach. And you might be right. That's why I ask you for feedback, okay? To improve. But if you're not doing your part and you expect me to just create miracles and have a magic wand for you to understand, that's not how any of this works, okay? So please start trying. Please take advantage of the fact that I'm very flexible with this, because not everybody is like that, okay? And once you start the semester, next semester, it's gonna be a whole different thing. Pre-calculus, it's a whole different beast, okay? And statistics is the same thing. It's not difficult. None of them are difficult if you study and if you do what you're supposed to do. But if you don't study, if you don't ask questions, if you don't look for things on your own, if you're just waiting on me to give you the stuff, then that's the reason why we fail, okay? Because you don't even try and you don't go the extra mile. Anyways, so I'm going to show you how easy this is. So when you take your test tomorrow, if you want to retake it, then you're going to do well. Obviously, it's not going to be the same thing. They're not going to be the same questions. They're going to be similar, but they're not complicated. So don't have that negative feeling that this is complicated. It's not. You really have to just pay attention to what you're reading. Okay, enough venting. Let's move on. So it says the weight of each cookie in a batch of a certain type of commercially produced cookie follows an approximately normal distribution. So it's a bell shape with a mean of, it tells you here what the mean is, 1132.32, and a standard deviation of 0.03 grams. Okay, first of all, if you don't have GeoGebra, you need to get technology that works or go to an online calculator. I don't know. But GeoGebra is the easiest, in my opinion. So you put that in there, and then it says approximately what percent of the cookies weigh between 11.32 and 11.35. So really the only thing you gotta do is just come here and plot the numbers. So 11.32 is the mean. 11.32 is the mean. And 0.03, it's the standard deviation. All right, so that's that. And then the question is, what percent of cookies weigh between 11.32 and 11.35? So 11.32, I will change it here, and then 11.35. Just give time for the program to load and calculate the area. And it's simply 0.34. So that's it. Like, there's really nothing else to do. What's the answer? The answer, yes, answer in incomplete sentences, or if you want to just write the number, that's fine too. I'm not deducting points for that, but 32%, that's it. You don't have to do anything else. All right, let's move on to the next question. When Alina throws a shot put through during track and field practice, it travels an average of 26 feet. Average. What's another name for average? Okay, what's another name for average? That's the mean. So the mean in this case is 26 and the standard deviation is 3. I mean, it's pretty clear. Some people were just like telling me random, oh, I'm sorry. Some people are telling me with just random numbers. I was like, where are you getting these numbers from? You're not even reading the question. Good Lord. So, but anyways, so 26 will be the mean, and then the standard deviation is 3. And then it says what percentage of her shots will travel less than 23 feet. So 23 is right here, so I just need to, it says less than that, so that means I need to move this way, less than that, 23, and then I move these, and that's 23. There. That's it. Look at the percent here. It's 0.16. So the answer then is 0.16, or if you want to say 16%. If you wrote it as a decimal, I gave you credit, still fine. It says percent though, so 16%. And that's all, okay? It's not super overly complicated that you need, science to do these. Like, it's not. So try it again, and then I will be more than happy to change your grade. Okay, next question. I don't know how to pronounce that name, so Priya, I don't know. That person looks at this histogram of a distribution with a mean of 5.6 grams and a standard deviation of 1.4. She claims that approximately 68% of the data is between 4.9 and 6.3 grams. What is the error in her thinking? So first of all, they're telling you that is wrong. And some people still said there is nothing wrong with it. I was just like, Lord have mercy on my soul. These kids are not even reading the question. Like, how do you say that there's nothing wrong where it clearly says there is an error? So that's how I know that you're not even reading these. And on top of it, some of you are cheating and you're getting the same wrong question. Like, oh, God. Okay, so it's wrong. This is wrong. So let's look at the mean. Let's put the mean in here. The mean is 5.6. So 5.6, and then the standard deviation is 1.4. So if you pay attention to the empirical rule, you know that it's the first standard deviation within the mean, that it's the 68%. So that means this big chunk right here. So according to this, okay, 68% of the data is between 4.2 and 7, not between 4.9 and 6.3. So that's the mistake. The mistake is that this person had the wrong standard deviation or calculated the wrong standard deviation, and the actual number should be between Oh, I'm sorry, let me close this. It should be between 4.2 and 7, not between 4.9 and 6.3. I gave you half a point, maybe 1 point for some of you who were maybe just made a mistake in one of the numbers, but that's all you had to do. Like, there was really nothing else. Okay, so something in the words of this person got the wrong standard deviation. It should have been between 4.2 and 7. That we should have done it. Okay. All right, next one. It says a restaurant offers 5 appetizers that the manager thinks to sell equally well. After looking over the sales for the previous month, the percentages of sales are bruschetta 17%, pasta bread 22%. Ugh, I'm disgusted by pasta right now. Even just thinking about spinach dip. Ugh. 21%, meatballs 23%, and a sampler 17%. Based on these results, is the manager's think accurate? Explain your reasoning. Okay, so think of it if you are the owner or the manager of this place. Okay, you're looking at the sales from the previous year, from the previous month, and then let's look at how far they from each other, right, in terms of percentages. So 17, 22, that's how much? Like 5%, then 21, that's just 4% from the 17, then 23, that's 6%, and then 17. It's really not that big of a difference. So based on this result, is the thinking accurate? Yeah, it is accurate. Okay, it is accurate because they're not that far off. So if you said no, I would suggest you double check it again. Some people say that it's correct because it adds up to 100%. Great that you add it up, but that's not the reason why. It's because all of them are around that 20%, which is, it's fine, right? So 17% is just 3 away from that, and 23% is just 3 away from that too, from that 20%. So the results are, you know, his thinking is pretty accurate. So if you said no, just double check your answer. All right, number 5, it says the distribution of weights of bags of chips is shown to follow an approximately normal distribution as seen in this histogram. The weights of approximately 95% of the chips bags fall within the shaded region. Okay, this is a tricky question, and I think only one person in my honors algebra 2 got it correct. The weight of approximately 95% of the chip. Okay, what is approximately the mean of the chip bag? I thought every single one of you was gonna get this one right, at least A, but no. Some of you still don't know that the mean is in the middle, so the mean is 10 for those of you who are struggling, okay? The mean, it's always at the center. And then what is the standard deviation? The standard deviation is not 0.2. Why is not 0.2? Because this whole thing represents the 95% of the data. So count how many numbers from 10 to 11.2. Okay, what's that difference? What's the difference? That difference is 0.12. So what's half of 0.12? Okay, half of 0.12 is 0.6. So the standard deviation is actually 0.6. Think of it this way. This whole chunk right here, let me do it with another color. This whole chunk right here is 1 bar. Okay, and then this one from here to here is another one. So from here to here, okay, is the 68%. Okay, and this 3 right here, and then from here to here is the other one. So this whole thing, okay, is the 95%. So the chips here, so here is 10, and then here is 0.6. And then for this one, it says, when Lynn drives a golf ball, it travels a mean distance of 200 yards with a standard deviation of 20 yards. Check what's the percentage when it's less than 180. So here I have my mu of 200, standard deviation of 20. If you move this around, okay, just put it where 180 is, and then we want to know what is less than that, okay? So less than that will be 0.16. So that's the answer. The answer will be 16%. And that's it.